Hello, I'm Gary Parker. Welcome to day 2 of linear models and statistics. So linear correlation, least squares regression line, line of best fit, trend line. Those are the things we're playing with. They're synonymous in this context. There are some videos. This is my day 1 video, specifically videos on how to do scatter plots and correlation with Google Sheets or StatKey or Excel with TI-84. Textbook, good thing to check out. Scroll all the way to the bottom. I have some sample data to play with. So in the first video, I went over playing around with federal minimum wage estimates over time, bicycling times versus distances, and flu cases versus deaths. Some other interesting data I have here. Per capita chicken consumption in the United States versus Montana average daily precipitation. So that's one we'll check out here. You could look at this one here. Sour cream consumption versus motorcycle riders killed in non-collision transport accidents. Interesting. Other data we'll take a look at. Murders in metropolitan areas versus, say, poverty level or unemployment rates. Blood alcohol content versus the number of beers one drinks. So we're going to check those out here. So linear models, they are things that look like y equals mx plus b, remember? M is your slope, rise over run, change in your y values divided by change in your x values. So the y is our dependent variable. So I have change in my dependent variable divided by change in my independent variable. And this is important for many reasons. One is it tells us how to interpret the number that we get, and we'll look at a couple of examples of that. The y-intercept, sometimes referred to as b, is really a point. It's the point 0b, where 0 is the x value at that instant, and that's a y value. So slope tells us about change, and the y-intercept tells us about a particular instance in the situation. An x and a y that are supposed to be related. And then we have the correlation coefficient, and the correlation coefficient tells us how good a fit the two variables are to each other with respect to a line. R itself will be between 1 and -1. If it's positive, that means we have an uphill trend. If it's negative, that means we have a downhill trend to the data. So an uphill trend means that the independent variable is increasing. And so does the dependent variable. With a negative correlation, negative is not a bad thing here, it just means that as the x value increases, where your x's happen to be, the y values will decrease. Other thing about R is if you consider its absolute value, so its closeness to 0 or 1, always going to be bigger than 0, and it could be 1. That means the points perfectly line up. This just tells us the strength of the correlation. So 1 is as strong as you get. So that would be strong correlation, and towards 0 would be weak correlation. And correlation is just a measure of the fit of a line to the data. So example, blow that up a little bit. So here I have per capita chicken consumption versus Montana precipitation, and these points do have an uphill trend to them. I have a slope here according to the spreadsheet. M is 0.0291. I have a y-intercept, that's the point 0, negative 0.424, and they give me r squared, so I'm gonna have to get r out of that. So let's take the square root, QRT of 0.6, I believe it was, that'd be about 0.77. So r in this case is approximately 0.77. So it's not super strong, like 0.8 or 0.9, but it's not very weak below 0.5. So there's some correlation between these two variables. Now, that doesn't mean there's causation. I have no idea if chicken consumption contributes to precipitation in Montana, or if Montana precipitation equates to more or less chicken consumption. That's a whole other question some scientists can take up. I'm just a mere statistician. So interpreting slope. In order to do that, we again have to remind ourselves what's changing here. So change in y, change in x. What is y here? Well, y is average daily precipitation in millimeters. So change in precipitation millimeters. X is change in consumption of chicken. So let's call that change in chicken in pounds. And so now I want to write my slope as a fraction. So that would be 0.291 over 1. So this is millimeters, and this one is pounds. So another thing to think about is we write these as y equals mx plus b, and in that form, x is the independent variable and y is the dependent variable. And so when we state what the change means, the independent variable drives the dependent variable. So I'll always start off my sentence with the independent variable. So something like words that describe a positive rise. So that could be an increase, it could be rise, it could be more. There's lots of words that are synonymous. So an increase of 1 pound chicken consumption. I probably should squeeze in per capita chicken consumption. Something like leads to an average increase of about 0.0291 millimeters in Montana's average daily precipitation. And there's many ways to word this, but what you have to get across here is, since this is a positive slope, that's an increase and that's an increase. So you have to reference the fact that these are changes in variables, not actual values of variables. It's a very important distinction there. And that the independent variable drives the dependent variable. And sometimes it's obvious which one is independent and which is dependent. Sometimes it's a matter of preference. The y-intercept here, by the way, that would be, let's see, if US consumed no chicken per person, then Montana would have negative precipitation. Not sure what negative precipitation means, so I'm going to strike that and say, well, that doesn't seem to be meaningful. And again, what does the correlation coefficient mean? It means that there is some correlation, might even argue it's strong, between chicken consumption and Montana's average daily precipitation. All right, let's try another problem. So this one I grabbed from StatKey, and StatKey has a whole lot of data. This came from the descriptive statistics, 2 quantitative variables. It's called bivariate data. You could take a look at the data. You could bring that to a spreadsheet if you wished. There's a prettier version here. So I have a measure of pH in a lake in Florida and the average mercury levels of each lake also. So this point right here means that there was a lake that had a pH measurement of 5.2 and the average mercury measurement was 0.25. I'm not sure what the units of mercury measure here. We'd have to look that up. So if you ever do come across a data set here and you're not sure what it is, feel free to send me a note or ask me, or we could write to Lock5Stat and ask if they know, which they should somewhere know that. So what do we got? Let's see. According to StatKey, there's the slope, there's the y-intercept. So the equation would be y equals negative 0.152 x plus 1.531. Okay, let's interpret the slope. So to do that, I have to write down my setup guide, change in y over change in x. What is y here? Mercury. So that's change in mercury. Let's call it mercury level because we don't know how to measure it exactly. Enough. And then the x is pH, so change in pH. All right, so the slope here is negative 0.152 over 1. And so this right here must be the mercury, and this right here must be the pH. All right, so usually we let the independent variable be positive, and then the negative gets to the numerator for the dependent. So I would have a sentence that looks something like this: an increase in the lake's pH will lead to a decrease, because it's negative, of 0.152 in the mercury level. There's many ways to word these, but again, you got to indicate whether the change is increasing or decreasing, what the value of the change is. So an increase, oops, I missed the value of the pH. An increase of 1 in the lake's pH will lead to a decrease of 0.152 in the mercury levels. And I don't need to put the negative there because I have the word decrease. That means negative. Usually it takes me a couple of drafts to get a reasonable sentence that my mom or one of my colleagues would appreciate. Let's see, what about the y-intercept here? The y-intercept would be the point 0, 1.531. The 0 is pH, and that is the mercury. Yeah, this actually might be meaningful. If the pH level of the lake is 0, we would expect the mercury level of the lake to be 1.531. So this one actually has a reasonable interpretation. And sometimes the y-intercept does, and sometimes it doesn't. It depends on the context. The slope should always be meaningful. Correlation, what do we got? Negative 0.575. So it's not too weak, it's not too strong either. There is some correlation. And if you can't see the downhill trend to this data because it's cloudy, StatKey will show you the line that it calculated. So that's the line in there. That shows the slope. Now that slope may look kind of steep there, but again, these scales are not the same, vertical and horizontal, so slightly stretched. And that's that. We have a negative correlation here. It's not a strong correlation, it's not a weak correlation, it's just a correlation. And we can interpret both the slope and the y-intercept in meaningful ways. All right, let's try another example. So that was StatKey. Let's check out murders. So let's see, we have examples here. All right, that's it for this page. Next, back to the spreadsheet stuff. So if you click on the murders and you want to play with this, then you would either, you'll have the view-only version of it. You could make a copy of it, give it a name, put it somewhere, or you could download it as maybe an Excel spreadsheet. So I have a copy of it over here I've been playing with. So these are 20 randomly selected metropolitan areas. We have the population. And for any particular metropolitan area, we know the population, the percent in poverty, the unemployment percentage, and the murders per million in that metropolitan area in a given year. Here I chose to graph unemployment versus murders per million. So that's what you see plotted over here. You should always make a scatter plot. We could just calculate the slope, the y-intercept, and the correlation coefficient. I'll do that in just a moment separately. So usually I start off with a scatter plot and think, well, yeah, that looks like there's some correlation there, but the points seem to head in a particular direction together. And so to turn it into a graph, we would, a line graph of the regression, we would need to edit the chart. And then we would need to customize the series. In this case, I want to add a trend line. I want to label it by using the equation and show r squared, the coefficient of determination. So let's zoom that into a new chart. To a new sheet. It doesn't appear to be much bigger. It's a little better. So we have a slope of about 7, a y-intercept of negative 28.5, and an r squared of 0.748. So we need to look at r, so I should take the square root of that number. So square root of 0.748 gives me a correlation coefficient, yes, there we go, of about 0.86, and that's pretty strong correlation. So yeah, it looks like unemployment percentage does correlate in metropolitan areas to murders in trillions. So what does that mean? Well, that should mean is if I know that one metropolitan area has a higher unemployment rate than another, then I would expect to see more murders in that other metropolitan area. And this line gives me a way to estimate that. Now, the line's not going to dead-on nail it, but let's try. Suppose there was a metropolitan area that had an 8% unemployment rate. Then that means if we trace over to the scale over here, maybe there would be 28 murders per million, roughly, in that city. Now, again, this doesn't nail it directly. There is some spread to the data, so I might be a little more reasonable. And there are ways to estimate ranges. We're not going to get into that in this course. But I could come up with a way to say, if the unemployment rate is 8%, then we would likely see 20 to 40 murders per million based on that 8% unemployment rate. Does it seem reasonable that there is a correlation between unemployment and murder rate? Well, if somebody is without a job, they could be very frustrated and angry, and a lot of people have guns in this country, so perhaps that could lead to a murder. Maybe somebody lost their job in a way that was not, well, I guess losing all jobs kind of suck, but maybe there was something that really upset the person that lost their job. I don't know. So that would be, to figure out if there's causation, we would have to study that further. So we need a lot more information than just the unemployment rate. But they do seem correlated. One seems to predict the other. Okay, so back here. So we could try and interpret what the slope means in this situation. So I'm going to show you my interpretations on the next page. Instead of having the chart calculate the slope, y-intercept, and coefficient determination, we could use some formulas. So for example, here I calculate the slope and it didn't come over properly. That's bizarre. I'm going to recalculate it. To calculate slope from a data set, you type the command slope. You have to select the y data first. This is important. If you don't get that order right, it'll get messed up. Comma, and then the x data second. And otherwise you will not get the right slope. So there's my slope of about 7. Y-intercept is pretty similar, equals intercept. And then y data first, comma, x data second. Close parentheses. And this right here, the 0.86, that is the correlation coefficient, not the coefficient of determination. That is called Pearson. Why Pearson? Well, the Pearson was a statistician, very famous, and he is one of the pioneers of this method. And it's called the Pearson correlation coefficient. So Pearson and the data, so y data, comma, x data. And it turns out with the Pearson correlation coefficient in this context, it doesn't matter whether you do x or y, but since these two require y first, it's a good idea to just keep it that way. These are way more decimal places than I need, so I can knock those down quite a bit. That's good. There we go, that's good enough. So I have strong correlation. Y-intercept, what does that mean? Well, that would be the point 0, comma, negative 29-ish. What does x mean here? X is an unemployment rate. So if we have no unemployment, there should be negative 29 murders per million. that doesn't make sense. Right? So again, sometimes the y-intercept makes sense, sometimes it doesn't. Slope, on the other hand, we can interpret. That would be viewed as 7, let's call it about 7 divided by 1. So 7 is the y value, so that's murders per million. 1 would be the unemployment rate, so that would be interpreted as 1%. So this is 7 change, I should say, let's rewrite that, plus 7 murders per million. I'm just going to call them murders divided by 1% unemployment. Type that. So plus apostrophe in front of that, and it should settle down. And that would also be a plus. So then I just need to put that in words. So here are my words for that. For each increase in 1% of the unemployment rate, the average number of murders per million people should rise by about 7. Okay. So I have an increase in the unemployment rate leads to an increase in the murders per million. Ratio is 1 to 7. So you just put that in plain language. You could interpret the y-intercept here, and that would be if the unemployment rate is 0%, then there should be about negative 29 murders per million. And in this case, I wouldn't, slope is an increase or decrease. The y-intercept is not, it's a static point. So that doesn't mean a drop in 29 murders per million. That actually means negative 29 murders, which doesn't make any sense. So this is meaningless. So we could strike that out. And then it's kind of a matter of opinion in this situation. I believe there's a strong correlation between unemployment rate and murders in a metropolitan area. And my evidence of that is an R value that's relatively close to 1, 0.86. All right, so there are other ways to talk about test for significance of correlation with these linear models, but that would be in a second course in statistics. We're not going to get to that. Okay, last example. So again, the importance here for me is, can you interpret what the slope means? That's one of the most powerful findings we have when we do these linear regression models. So here I have a situation, let's blow that up a touch. A study that was done at a university, Ohio State University. So sometimes there are these thoughts that how drunk you get after you have some beers depends on, well, how much do you drink normally? Maybe you've built up a, quote, tolerance, whether you're male or female, how heavy you are. They're trying to get at what really matters is how many beers you drink, bottom line. So they did a random selection of students. From that selection of students, they took some females and some males, and they had to agree to drink a certain number of beers. The number of beers was also randomly selected. So I have students identified by number, and then the data we're graphing here is the number of beers they drank and the blood alcohol level, which was measured by a police officer. And if we look at the graph of that, again, there's a pretty strong uphill trend to that. So the more beers you drink, the higher your blood alcohol content. According to the chart, the slope is 0.018. I use the slope function here, and I could have it display more decimal places if I wanted to. It rounds to 0.018. The y-intercept is a negative number. What do these things mean? So let's see if we can calculate, interpret them, excuse me. So what would the slope mean in this context? Well, the slope is rise over run. So rise is my BAC, blood alcohol content, and runs are the number of cans of beer. So if you view that as a fraction over 1, we have M, which is change in blood alcohol content versus change in number of beers. And that's equal to 0.018 about. To make it a fraction, we put it over 1. So this would be, again, BAC, and this would be beers. So what this tells me is an increase of 1 more beer will lead to an average, and this is an average, increase in blood alcohol content of about 0.018. All right, so for every additional beer you drink, you should expect your blood alcohol content to increase by 0.018. As far as the y-intercept here, if we went to interpret that, it would be the 0.0 for beers and negative 0.0128. So if you didn't drink any beer, then you would have a negative blood alcohol content. So unfortunately, that doesn't make sense here. And R, the correlation coefficient, is almost 0.9, which is a pretty strong correlation here. We have sufficient evidence in terms of modeling this with a line and having this slope be something relevant to the problem. Sometimes we can talk about picking a more realistic intercept. In this case, the intercept should be 0. If you drink no beer, your blood alcohol content should be 0. That would be a shift up from this negative y-intercept, which would, this line would keep the same slope, but it would just rise up a little bit, probably take it outside the data, in which case it's just a line that's outside the data, but it has the same slope. But the y-intercept actually should be 0 here. And sometimes we do consider that. So that's it, playing with linear models using the linear regression. This week's application, which you're going to start at soon, is for you to find some bivariate data, that is 2 variables where you have collected values where each is related to an individual somehow. It could be an individual person or an individual thing. If you're not sure about data, you can go to the stat key and search through their data sets and pick something that looks interesting. If you're not sure what their data set means and it's not obvious from looking at it here, then send me a note and I'll help you figure it out what each variable represents. Because in order to interpret this stuff, we do have to know what the units are of each variable. Based on that, you are going to make me a nice, well-labeled scatter plot. You're going to include the regression equation and the correlation coefficient, and then you're going to answer the following questions and submit that. That submission could come by just typing it into this box right here and including your graphics, or you could put this together in a spreadsheet, or you could put this together in a word processor if you had used StatKey for all of your work, because StatKey pretty much calculates everything you need here. You just need to answer the questions based on it. All right, good luck, have fun. Contact me if you have any questions. That's it for now. Bye-bye.